Hello and welcome to Challenge to Build, and in today's video I answer a question from a viewer regarding this welder here. This is the Tooliom TL-200M 3-in-1 welder. I purchased this a few months ago to see what kind of welding experience could be had from buying a budget welder off of Amazon. So I did an initial unboxing and review on this welder, and when I was doing the review, I was welding on 220 volts with solid wire and shielding gas. And the question that I received just a few weeks ago came in from Lucas Ariel Barrera. And the comment in question reads like this: Amigo of Challenge the Build, thank you for your video. This is one of the best ones on YouTube about the Tooliom TL-200M 3-in-1. I have exactly the same machine, but I don't have success like you because I tried to weld on 110 volt. I do not have 220 volts outlet. Could you do another video testing with the same welder, but on 110 volts with gasless wire or flux? I'll appreciate it a lot if you do it, and I'll learn how to adjust the welder in 110 volts. Thank you from Tucson, Arizona. So you are in luck, and that's what this video is going to be about. Now, before I get into actually welding with this today, there's a few things that I do want to talk about that will hopefully help set you up for success in welding on 110 volts. Obviously, this machine is set up for 220 volts, so you will need the adapter, which is what we will be doing today. The majority of the outlets that are in your common home or garage are going to probably either be 15 amp or 20 amp outlets. Depending on your outlets will depend on the overall success you will have welding on 110 volts. Ultimately, to have the best chance of success, you are going to want to have a dedicated 20 amp outlet and then use a good heavy-duty 12 gauge extension cord in order to get the most amperage from the outlet to your machine. And obviously, the smaller length of cord you have, the better it will be also. You will see a little bit of an amperage drop, saying if you were going to use like a 25-foot cord opposed to a 100-foot extension cord. So a good grade 12 gauge heavy duty extension cord is a must. This is obviously a budget welder, and when I say budget welder, I generally, for me personally, I classify a budget welder as anything under $500 or less. With budget equipment, they are not built to the same quality standards as some of your higher grade equipment, such as like a Miller, a Lincoln, or a Hobart. So these budget machines are very power hungry. It is extremely important for you to read the user manual and also do your own due diligence in how you plan on using the machine and setting it up. Along with changing the voltage to 110 volts today, I am going to use Flux-Core wire, and I'm going to use a light wire. This is 0.030 Flux-Core wire. I think this will give us the best chance to weld consistently with lower power consumption. So now what I'm going to do is take a few minutes and set the machine up, switch out the wire, and then there's going to be one very important piece of information that we are going to talk about here in just a minute. So watch as I set this machine up, and then we will get into the actual welding. Now that I have the machine switched over to Flux-Core wire, there is one more very important thing that I need to do, and that is going to be refer to our little cheat sheet that was given to us with this machine. In the first video, I found this to be very helpful in finding the settings needed to weld certain thicknesses of metal. And this goes over all of the processes as far as this machine is capable of: MIG, lift, TIG, and arc welding or stick welding. And if you look down here on the bottom of this little cheat sheet, the very first one on the left, it specifies Flux-Core welding and how you set up the machine for this process. And you need to weld on DCEN, which is DC electrode negative. And if you look at the diagram on the machine, it shows you exactly how to set it up. And in order to do that, what I need to do is take out the lug here. Then we are going to take the grounding clamp and actually put it on the positive lug of the machine. Now this is kind of one of them things that it's like, does this even make sense? Because negative and positive, like you don't expect your ground cable to be on the positive lug, but it's how this machine is set up. So again, it's very important that we read, understand, and follow the instructions to have the best outcome. So the ground clamp goes on the positive lug, and then this wire that we disconnected from the positive lug, this loose one right here, then goes to where the grounding clamp was installed. And this now completes the setup for us to be able to weld with Flux-Core wire using this machine. So big difference from welding with solid wire to Flux-Core wire. So now the machine has the wire, the polarity is correct. I have my welding helmet, my welding gloves. One thing, when welding with Flux-Core wire, you do not necessarily have to use the nozzle. They make a plastic cover that slips over the tip to cover all of these gas ports and these threads. This way here you can expose the tip and have better clarity when welding, but I do not have one of those, so I am going to leave the nozzle installed. So this way here it's kind of protecting all of that stuff, and it doesn't really hinder me from the welding that I'm going to do. So all that's left to do now is get into some welding. As far as material, I have a little bit of an assortment. I have 1/8 inch wall square tubing. So I'm going to kind of do one of these situations, I guess. I don't know, try to figure it out as best as I can as I go through it. I also have 14 gauge sheet metal. I'm going to do kind of a joint like this, which will allow me to have a weldment here and also on this side here. And then just to test the limits, which I don't necessarily think 110 volts is going to be able to do it, but just to test the overall limit of the machine, I have 1/4 inch steel plate that I will just do kind of like a T-joint and see how we do. One thing to help aid in weld quality is the cleanliness of metal. So I have my Milwaukee grinder with a flap disc. I'm going to throw a battery on this, clean all the material up to ultimately have the best chance of success with welding. So all that's left for me to do is to continue to challenge the build and finally get to welding. So hopefully I've answered some of your questions and we will have success in our welding. And you will see me refer to this cheat sheet again. So it's been a little while since I've used this machine, so it'll be a learning process for me as well. All right, first up, we're gonna hit some 1/8 inch material. Throw the ground on. And let's see what we got. Flux wire, DCEN, no gas. This calls out 035. I'm using 030 because I think it's going to give us a better chance. 150 13 gauge, 16.5, and inductance, we're going to say high, and we're just going to max it out at that and I guess see what it does. One thing that you're going to need to make sure is up here on the mode setting, make sure that you switch it over to flux. So we're going to just go right for maxing this sucker out and see what happens. Like I said, I think at 110 voltage, I think 1/8 inch is going to be the max that we're going to get. So here we go, Flux-Core, weld. I don't have a chipping hammer. And I haven't practiced, I promise. This welder has been sitting on the shelf for a few weeks, maybe even a few months now. I generally weld with shielding gas. And considering that was right out of the box, the first weld, I will give you a close-up picture of that right now. That's pretty impressive. So again, this is 1/8 inch wall material, and I just went full on all the way up. I went 0 to 100 real quick. I have high inductance set on my left knob here, and I have this thing fully cranked up to 161 on my wire speed. I'm using 030 Flux-Core wire, and that was my first weld, and that's a pretty darn good attempt for the first one. So I'm going to do it again. Now on the side joint, the roll of the tube is allowing me to have like a bevel, so I expect this one to be even better. And considering what that one looks like, I'm not even going to adjust the machine. So here we go. I'm going to push too. And I'm also in the process of doing a test on my PureCare air purifier, my air filtration system up here. That's what you might be hearing me play with now. I'm trying to get the air circulation. Another thing you're going to want to do is make sure you keep your face outside of the welding plume and have good ventilation with fresh air while you're doing welding of any kind, for that matter. So that's weld number 2, and it actually looks like it's a really, really good looking weld. I promise. I'm just as surprised as you are, and I can only hope that with what I've been talking about in this video will help you achieve the same success. And a lot of that has to come down to really just reading and understanding the user manual, and then also spending time with the machine, just playing with it. Remember, this is supposed to be fun. The more fun you have with it, the better chance you will have in producing better welds. You certainly don't want to get frustrated. If you ever get to the point where you're trying to learn how to do something, and it really applies to a lot of different things in life, but if you ever are trying to learn or teach something, when you get to the point of being really frustrated, sometimes the best thing to do is just put it down, walk away from it for a little while, and then clear your head and come back to it to try it again. It just takes time under the hood. I've been welding probably for well over 20 years, and I still am not as good as I want to be. And just recently, I've just started to learn how to TIG weld. So it's a process, and it takes time, takes a lot of practice, and a lot of trial and error. So I'm going to run another weld, and here we go. Now, ultimately, my start and stop technique wasn't the best on that one, but here are some of the actual welds that I just have done on this 1/8 inch. My start stop was not the best. Now this is where having that nozzle off will really come into play, because it will allow us to get tighter in there, but I don't have the protector, so I'm going to just go for it. So now that we've had some success with the 1/8 wall material, I'm going to switch to a 14 gauge material. Now for 14 gauge, 16, 13, it says 115 for 16 gauge, 150 for 13. So we're going to kind of split the difference. And I think I'm going to come down to, we'll say 130, and we're going to go normal inductance, and we're going to see how that works on this here now. Here we go. Again, all things considered, I'm very satisfied with the overall weld. You can see I have really good penetration coming in on the back of the panel as well. Hot. So now with the success that I'm having with the 14 gauge and the 1/8 inch material, I am going to try to weld the 1/4 inch. However, it is not rated to weld 1/4 inch material at 110 volts. Now, I could probably kind of bevel the edges to help me get the proper penetration, but I am gonna this is more for humor, I guess, humoring myself to see if it has the ability and what we can achieve. And in order to do this, I'm going to again turn the inductance knob all the way up to high, and I'm gonna actually run it at a little bit slower speed of like 150 to see what it will produce. So here we go. Throw a couple tacks on it, and let's run a weld. I'm going to slow it down even more. Definitely not much penetration going on in there, which I didn't think it would. I mean, I'm not totally unhappy with that. I tried to maybe try to do a little weave technique over here to kind of keep a little bit more heat and kind of weave it in. This was 150, and then I started to crank it down, and then ultimately I have it set at like 130. So now I'm at 120. I still have my inductance set all the way up to high, and we're going to try it again. Try 160. Well, I definitely think I found the limits of the machine. And I didn't really expect it to weld the 1/4-inch plate all that well. It did do it, but it definitely needs some more heat. So, well, overall, I think the success that was had with 110 volts with the Tooliom TL-200M was pretty successful. I would say that 20 amps at 110 volts, I would say 1/8 inch is probably about the max material thickness for welding. You could probably weld a little heavier, maybe upwards of like 3/16, but you would definitely have to take your time and prep the metal, put a bevel on it, make sure everything's nice and clean. Anything beyond 3/16 would probably need to be preheated prior to welding. One thing I'm noticing running 20 amps is this machine can run more amperage on 110 volts, so I'm limited to my 20 amp breaker, because in this little cheat sheet, I should be able to raise the dial all the way up past 160, but I think it kind of regulates or can pick up how much amperage is getting put into the machine. I feel like if you were to hook this up to 110 volts at 30 amps, again, using the proper gauge wire and outlet and breaker, I think you would be able to get a little bit more welding current out of it. I think overall it was a pretty good success. So hopefully this was able to answer some of your questions. Potentially help you learn how to set up the machine for different material thicknesses on the lower voltage. If there's any comments, questions, or concerns, go ahead and post them up in the comment section below. Now it's time for you to go out there and challenge your build. Remember, have some fun and just time under the hood, get the experience, and you too will have some success welding and building your projects. So thanks for watching. I will see you in an upcoming video.